Okay guys, welcome back. So in the last video I concluded by explaining about different actually the special occasions in which forces and theories on mechanics come into play. So that was the second part of mechanics, my second series of videos on mechanics. So as the last series I will begin this video on the characteristics of forces. So in the last series of videos I'll explain you about what is meant by a force. Now you know already what is meant by a force, what are the characteristics of different forces, how to calculate the resultant of a force system, how to gain or how to calculate the moment of by a force around a point, and what is the center of mass of a system, and finally the equilibrium of a particular system. So these are actually categorized into separate videos. So my actual intention of this video would be to explain you about what is meant by force and the characteristics of different forces. So to begin with, I will explain about some requirements for two forces to be equal. Now you know that force is a vector. It has both a direction and a magnitude. So when you drag some object or when you pull some object, you will exert some force. So that's one of the basic forces, one of the basic definitions of forces. Now when you have two forces, one important thing to remember or one important thing to question is how can these two forces be equal in both in magnitude and direction. So for two forces to be equal, we say that there should be four requirements that should be met. So one of the requirements is that they should be equal in magnitude. Now that's actually evident from although force is a vector, even it's a scalar, you can say that even if force was a scalar, if these two forces are to be equal, they should be equal in magnitude. And also force unlike scalars is a vector. Any force is a vector, so it has some direction and they should be of the same direction. What I mean by the same direction is that if this is actually pointing towards the upper direction, this force should be also pointing towards the upper direction. And another important thing is that they should be parallel, or they should display the same inclination. So what I mean by that is that now say this force now this force is actually vertical, you can see this, and this force is also vertical, so they are equal in magnitude. So that's the reason as to why I have taken F and F here, and they have the same direction. But although they are in the same direction, they can sometimes be not parallel. So what I mean by parallelity is that they should now if this force is say 30 degrees inclined to the horizontal, this force should be also 30 degrees inclined to the horizontal, but not only 30 degrees, it should be of the same direction as well. Now if this is the horizontal, you can see this is the horizontal, and if it makes 30 degrees, if this force makes 30 degrees with the horizontal in this direction, you can also make 30 degree horizontal in this direction, this direction, this direction, or this direction. So there are actually four directions in which you can choose from to make 30 degrees with the horizontal. But since they should be of the same direction to be equal, these forces should be like this, right? Should be in the same direction as well as of the same inclination. And the final important point is that they should be of the same line of action. So what I mean by the same line of action is that's actually the concept that I will be explaining in this video, and that means that they can be superimposed, or you can move this force over to here, and if you superimpose over this line in which the force is acting, that should display the same characteristics, the behaviors, the changes, and all the other properties that is expected from this force. So if you remove this force and if you take this force and keep it here, it should represent all the properties that this force represented when it was there. So that is meant by the same line of action. So actually this is the most important concept of when talking about forces, and I'll explain you deeply about that when I am progressing through this video. Alright, now having explained about what is meant by force and what are the requirements for two forces to be equal, my next topic would be to introduce you about the moment of a force. So what is the moment of a force? Now if you have some force like this, so I'll take actually from actually a simple example to explain you what is meant by a moment of force, and then I'll explain you what is the definition and how we define the moment of a force. Now assume that this is some object, just a plain object, right? A laminar object, you can say, And if you exert some force like this, so you can't actually exert a force inside this object. So that's the reason as to why I explained you about the line of action. So you actually exert a force externally here. So I have extended this line of action around this direction so that it meets somewhere here. And if you take the moment, if you take the concept of moment around this point, we define moment to be the product of force times the distance. And this force F and this distance should be perpendicular to each other. Now you know that force is a vector, although distance is a scalar. We consider that moment to be also a vector. So this actually we take here the cross multiplication, right? Cross multiplication. And because moment is a vector, the direction should also be considered in calculations. So the direction can be clockwise or anti-clockwise or counterclockwise. So moment of any point is important when explaining about the rotational dynamics of that object by a given force. So we define the moment, as I mentioned, as moment of a force around a point as the product of the force and the perpendicular distance between the force and the fixed point. So you have to take the perpendicular distance. Now in case that force is not perpendicular, if it is angular somewhat here, you should either find the distance from this point to the line of action of the force, or you should decompose the force so that you can find the perpendicular distance. So there are two ways to calculate the moment of a force, so that I'll explain that in the second part of this video. Now if you take a simple force system like this, so I explained about force systems when I was explaining about the introductory videos on physics, about scalars and vectors, their decomposition and finding the resultant. So you know what is meant by force system. So if you have some force system like this, say you have some rectangular object ABCD, and you have the following forces: F1 along CD, F2 along CB, F3 along AC, F4 along AB, and F5 along AD. Now you know that if you take the moment around a point like A here, first of all what you have to do here is that you have to find out what are the forces that take place and what are the forces that are subjected for this moment. Now since the forces of F3 here, you can see F3, F4 and F5 go through A, the perpendicular distance, the distance between the forces and A is 0. So thus the moment of forces around A is also 0. So you can say that there is no perpendicular distance. So although there is a force, for the moment to exist, there should also be a distance, although it's perpendicular or not. So if it has some distance, you can calculate the moment around that point. You can either decompose the force or find the perpendicular distance. But in either case, you should have some distance. So if you don't have a distance, or if it goes through the point in which you take the moment, what you have to do is first of all to eliminate those forces. So that should be the first step of finding the moment around some point. The second one is that we should categorize which forces create a clockwise moment around point A and which forces create an anti-clockwise or counterclockwise moment around A. Now in the case, you can say that F5, F3 and F4 has been ignored and the only remaining forces are F1 and F2. Now if you have some F1 force like this, so as I mentioned, this is the line of action. You can extend it to infinity like this, right? This is the line of action. So the perpendicular distance between F1 and A is this distance AD or BC, because this is a rectangle. Actually I'll take this to be a square, right? In fact, to be a square, so it's easy to calculate. So the distance between the force F1 and A is actually the distance of one side of this square. So F1 is in this direction and it creates actually counterclockwise or an anti-clockwise moment around A, because now if you drag this force here, it creates a force like this. So it's in this direction, it creates like this, right? So it creates a force like this in this direction. However, F2, when you take F2 around A, what generally happens is that F2 is actually acting in this direction. So F2 will create a moment around this force in this direction. Now you actually saw that in this concept. So if you have a force like this and if you have a perpendicular distance like this, so this force will create actually a moment around this point in this direction, because you can drag it, you can drag it this way, you can drag it this way, you can drag it only this way, right? And one important thing to explain here is that always the force makes a moment around the smaller angle. Now if you consider this direction, it makes an angle of 90 degrees, but if you consider around this direction or clockwise direction, what generally happens is that force has to make an angle of 90, 180 and 270 degrees. So that's one other another way of classifying moments around the point, the direction of moments. In fact, the force makes always a moment in, so that the force makes the smallest angle possible with the point of taking the point where you take the moment. So as I mentioned there, F2 is in this direction, so F2 should create a moment like this in this direction. F2 creates a moment like this, F1 creates a moment like this. So the moment created by F1, regardless of the magnitude, is in the direction so that it is anti-clockwise or counterclockwise. And F2 creates a moment around this point, regardless of the magnitude, it is in the clockwise direction. So our second step of finding a moment around a point is to classify them into counterclockwise and clockwise directions. And then what you have to do is that you have to take either the moments around the clockwise direction to be positive, or the moment around the anti-clockwise or counterclockwise directions to be positive. So if you take one direction to be positive, you know that the other direction should be negative according to the rules of forces and decomposition of forces. So in this example, what will happen is that now you can say that F1 creates a moment around A in this direction, and F2 creates a moment around A in this direction. So I'll take the clockwise direction as positive. So if the length of these sides is D, so AB equals BC equals CD equals DA, because it's a square, and if I take that to be D, you can say that the moment around point A is actually F2 times D, right? So I'll take the positive moment around this direction, so positive the clockwise moment to be positive. So F2 makes a clockwise momentum, so that is positive, and F1 makes a counterclockwise or anti-clockwise momentum, so that is negative. We have to subtract that. So the moment created by F2 in this direction is the force F2 times the perpendicular distance here D, so that will be F2D, and F1 is moving creating a moment in the anti-clockwise or the counterclockwise direction, so that is, we have to subtract that, or we have to take the minus sign. So that will be F1 times the perpendicular distance D, or that will be the difference of forces of F2 and F1 times the perpendicular distance. So this is actually an explanation as to how you can take the direction. Now you know how to take the magnitude. This is actually an explanation of how to take the direction. Now F1 is in this direction, so you have to take the moment around A. So F1 always creates a moment so that it exerts the smallest angle, and also the drag of force should make somewhat of a momentum in this direction. So due to these reasons, you can say that F1 creates a moment in the moment around A in a clockwise or anti-clockwise direction. In contrast, F2 should make a moment around A in a clockwise direction. So finally you will again get that the moment around A or GA to be the difference of F2 and F1 times D. Now if you take the moment around D, right, if you take the moment around D in either direction, you will also have to consider the inclined force. So that's an interesting situation where you get inclined forces to calculate the moment. So the first way, there are actually two ways of finding the momentum, finding the moment. Don't confuse momentum with moment. There are two ways of finding moment when you have inclined forces. One way of finding is by taking the perpendicular distance into account and then calculating the moment. So you can say that the perpendicular distance between F3 and D is D over root 2, because now we can say that this distance is D, this distance is D, so this is root 2D, and if you draw a perpendicular from here to here, this distance will be D, this distance will be 1 upon root 2 by 2 or 1 upon root 2d. So this distance will make it to 1 upon root 2d. So you know that this distance is 1 upon root 2d, and F5 and F1 go through d, so you can ignore those forces. So the total force or the clockwise moment around d is F2 times d. So F2 creates a moment around this direction, so I am taking the clockwise moment. So the clockwise moment around d is F2 times this distance d, and F3 and F5 are ignored because, F1 and F5 are ignored because they go through d. And by F4 creates counterclockwise or anti-clockwise moment around d. So that distance is again d, right? Simple d. So the moment is minus F4 times d. And when you take F3 also creates a moment around d in counterclockwise or anti-clockwise direction. In this direction, this is the force. This force creates a moment in the counterclockwise or anti-clockwise direction. So that we have to subtract that, and that force is F3, and the perpendicular distance from F3 to d here, F3 to d is d over root 2. So the final clockwise moment around d is as follows. So that's one way. The second way, as I mentioned, is actually dividing the inclined force into its vertical and horizontal constituents. Now if you divide these into the vertical and the horizontal constituents, what generally happens is that you can have perpendicular distance calculated in a straight way method. You don't have to calculate through geometric means, because either the horizontal or the vertical components of these forces should go through d. So what generally happens is that you can ignore one component and you can take the moment of the other moment created by the other component. Now if you take the same system here, so you know that this is a square here. So this inclination is 90 degrees. The angle between these two sides is 90 degrees. So this angle should be 45 degrees, or 5 by 4. So if you decompose this force along this direction horizontally and along this direction vertically, you will gain actually a force diagram as shown here. So F1 will be like that, F2 will be like that, F4, F5 will be like that, and F3 in this direction will be F3 sine 45, and F3 in this direction will be F3 cos 45. Now you can first of all, you should eliminate the forces that go through the point that we take moment. So F1, F5 and F3 sine 40 go through d, so their moment is 0, so we can ignore the effect created by those three forces. However, F3 cos 45, F4 and F2 doesn't go through d, so we have to calculate the moment. So when you calculate the moment around d, you can say that F2 creates a moment around d in a clockwise direction, and F4 creates a moment around d in an anti-clockwise direction or counterclockwise direction, and F3 cos 45 also creates a moment around d in a clockwise in a counterclockwise or anti-clockwise direction. So if I take the clockwise moment around d to be positive, I can say that the moment created by F2 is positive, but those created by F4 and F3 cos 45 is negative. So they should be subtracted, and F2, the moment created by F2, should be added. So when thinking about F2, this is the force F2, and the distance between F2 and D, the perpendicular distance, is actually DC or BA. So that distance is equal to the length of a side of the this square. So that is F2 times D, and the moment created by F4 around D is in the anti-clockwise or counterclockwise direction, and that is F4 times D, because this distance is D. And the moment created by F3 cos 45 around D is the same as that created by F4, rather than its magnitude is changing, it's counterclockwise, and the distance is d, so you have to subtract that as well. So you can simplify to find the moment around that point. Alright, so in this video I explained to you about how to find, so actually first of all I explained to you about what is meant by a force and what are the characteristics so that two forces are to be equal. And the second point I explained to you is the concept of moment of a force and how the moment of a force can be calculated when given some force system. Alright, so in the next video I'll be explaining you about some more concepts on my last videos on mechanics. So thanks for watching this video, and see you then.